All right, this is a video of intro to polynomials and end behavior. Here's slide 1, gives you examples of polynomials and non-examples. So what do you think a polynomial is based on? Examples and non-examples. Polynomials are in the form p of x equal a1 times x to the n plus a2 times x to the n minus 1 plus ... some coefficient x to 0. So in standard form, polynomial is put the highest degree of x down to the lowest degree. If it's x to the 0, then there'll be a constant term here. All these a values are real number coefficients, and the exponents are positive integers. So this would be a positive integers or 0 down to the lowest power of x. Once again, this would be a constant term. So all the exponents are whole numbers. So here's kind of an informal definition. Polynomial is a function where all the exponents are whole numbers and the coefficients are real numbers. The features of the graph of a polynomial are continuous. They have end behaviors that either go to positive or negative infinity. So both ends could go to positive and both ends could go to negative infinity, or they could go in opposite directions. Graphs have one less turning point than the degree. So at most, they have one less turning point. Could have less than that. And the number of solutions match the degree. So the solutions may be imaginary or repeated. So Gauss is a mathematician that came up with this idea that the number of solutions of a polynomial function match the degree. The solutions could be repeated or imaginary. So determine whether, this is where we left off in class, determine whether functions are polynomials or not. This is a polynomial. All the coefficients are real numbers. All the exponents, 5 and 1, are whole numbers. So that's a polynomial. The next one down, all the coefficients are real numbers. And all the exponents are whole numbers. So that's also a polynomial. The third one down in the first column, this negative, that's not a whole number. That's a negative integer. So that one's not a polynomial because of this here. And this would be 2x to the 0 power. So this is a polynomial. Functions, I should say. Maybe that should have been on the button. Polynomial function, not a polynomial function. Here, this one is not a polynomial function because if I made this a power of x, it would be x to the 1/2 power. And 1/2 is not a whole number. And then this one is not a polynomial function because of this 5i. It's imaginary coefficient. This one is a polynomial. -5 is a real number. 1 is a real number. 3 is a whole number. So that is a polynomial. This one's not a polynomial because of this exponent 1/2. And then slide 4 is just a note slide. So the leading coefficient here, this is written in standard form from the highest power 5 to the lowest power. So this would be x to the 0 here. So 6x to the 5th minus x to the 4th plus 2x plus 7. So the leading coefficient goes with the highest power of x. The highest power of x is called the degree. So this polynomial is in standard form because the terms are in order from the highest exponent to the lowest exponent. So 5, 4, there's no x to the 3rd term, no x squared term, then there's the x term. and then next to the 0 or the constant term here. The leading coefficient goes with the highest power of x, that's 6. The degree of the polynomial is 5, and this polynomial has 1, 2, 3, 4 terms. So put this polynomial in standard form. So f of x equals, so the highest power of x is 6, so negative 4x 6 plus x to the 5th. And then there's no x to the 4th term, but there is an x cubed term, 5x cubed. Then it's x squared term, 2x squared. Then an x term, so plus 6x, and then minus 8. So 5, 4, there's no power of x, which is 4. Then x cubed, x squared, x, and then x to the 0. So the leading coefficient goes with the x to the 6 is negative 4. The degree is the highest power of x, which is 6. How many terms does this have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 5, 6. So reviewing the answers on this slide, in standard form, negative 4x to the 6 plus x to the 5th minus 5x cubed minus 2x squared plus 6x minus 8. The leading coefficient is negative 4 right here. The degree is 6. And then the number of terms, 1, 2, 3, 4, 5, 6. All right, end behavior. What do you think? Describe the end behavior of the graph using your own words in the sentence starters below. So as x increases, let me say that again. As x decreases to the left, the y values increase to infinity. And then as x increases to the right, the y values increase to infinity. So rewrite using math language. The end behavior graph is what is going on at the ends, the left and right sides of the graph. Describe what happens to the y values of the function when the x values are very large or very small. In words, as x decreases to the left, the y values are going up forever. As x increases to the right, the y values are going up forever. In math terms, this is read as x approaches negative infinity, y approaches infinity. And then on the right, as x approaches infinity, y approaches infinity. So choose the correct end behavior. So as x approaches negative infinity, this is going down. So this one's not right. Let's see if this one's right. As x approaches negative infinity, f of x goes, or y values go to negative infinity. As x approaches positive infinity, y values go to infinity. This one's wrong because that's wrong. This one's wrong because that is wrong. Both of these are wrong, actually. This one is wrong because that's wrong. So it's this second one here. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. Choose the correct end behavior here. So as x going to negative infinity, y goes to positive infinity. That's correct, but this is not correct. So can't be that one because that's incorrect. This one's also incorrect. So as x goes to negative infinity, y goes to positive infinity. It's going to negative infinity, y goes to positive infinity, and as x goes to positive infinity, y goes to negative infinity. So it's this fourth one here. So on the left, the graph is decreasing. Oops. Graph is increasing to infinity on the right. So on the left, the graph is increasing to infinity. It's going up, and then on the right, the graph is decreasing to negative infinity. And then practice 3, choose the correct end behavior from the options. So both ends are going down, so you want to find where both y values are going to negative infinity. Right here is the option that is correct. So here, both ends of the graph are decreasing to negative infinity. So that's it for the intro to polynomials and end behavior.